in this video, we're going to talk about add to back. So far we talked about add to front, meaning adding a node in front of the list. Well, why not adding a node in front of, at the back of the list, right? So add front is basically reversing the order. So you may want the order to be just as it is, right? So think about add to back. Okay. Now, let's think about it. So initially, list is empty. So now there's what? Empty list. Okay. So now what do? You add back. Well, it's basically the same as that front. Okay. So the picture will look like this. Let's say this is 10. Okay. Something like this. Okay. So it's similar. Okay. So add front. Okay. So okay. Here's what we're gonna do. So we're gonna initialize the list with an empty list, and then let's say we're gonna have some input terminal. Okay, and then if something not an integer will come up, we're gonna stop the loop, and then just call add to back. That's what it is. And the prototype is, remember, list, but notice add to back. Let's write it. As we said, if L is null, okay, empty list, add a node. Add a node and then return. Node. Okay. So what I'm going to do is I'm going to also create adding a node. Add a node. Add a node. That's what it is. Okay, so what I do is add node function will be basically, sorry. Add node function will be basically what? Remember, this is what we do. Add a node, what add a node will be doing basically this job. Create a node and set to be V, and then the next pointer will be is B0. Okay. And then returns the address of that node. And then what? A single node. Add a node. Add a node. You create a node. And you set the data to be V, and then the next is basically basically create a node with the value V. The next is add a node. So add a node, because it's empty, basically the new list is basically that node. And then what? If L is not empty, what do we have to do? Now let's think about the scenario. What do you have to do? So now let's say you want to add 10, right? So the thing you need to do is you have to change this to be like that. Okay, so what is the thing to do? First, you have to, again, add a node, right? And then you have to find this guy, and so that the destination should point to that. Okay. Let's say this is like, I don't know. Let's say this is, we have to find this. And then let's say this is like some pointer called last. Okay. So we have to find, what is it? Last node in the list, right? And then basically this should be last arrow next, right? So that's last arrow next. So last arrow next has to be changed to, so that it points to what just returns from this add. Okay. So let's make a helper function. What do I do? Let's create a point of last. Then let's say, hey, function, find last. And then this function will do the job and then find out, gets us like the pointer that points to the last node. And then what? You do a last next. Should be last next should be changed to, right? So you add this node and then return it. Then you return what? Well, what you return is the list. And then well, the first list, the first element of the list, first node of the list doesn't really change. So L doesn't really change. The pointer L value itself doesn't really change, but right at the end of the day, somehow the last point has been changed. Anyway, what you return is this L. Okay. Well, what do we need to do? We have to find we have to create a find the last. How do you know? How do you know, this is the last? Remember, the list originally looked like this, right? Let's see this. Let's say 10. Yeah, let's just do that. 20. Okay. So how do you know 20 is the last node? Well, because of this. Well, there's nowhere to go next, right? So what's the condition? Let's say T is pointing initially to here, right? And then move next. And then if T points to here, then we have to know what this is the last node. How do you condition? What's the condition? If this guy is what? T next. Right? T arrow next. If T arrow next is 0, if T arrow next is null, right? That's when you know, oh, this node is the last, right? So basically, what do? You keep scanning. You just do that, scan the list, and then if T next is null, you find the last. Okay. You should be able to return T probably here. Okay, so this is not really a problem. This is a problem area. Probably you won't reach here. Anyway, I'll say it. This is really a problem. We'll say maybe here. Long. And then maybe I just okay. Anyway, so that's basically add back. So let's recap. So for add back, if the list is empty, well, you create one node and then return that node as a new list. Okay. So for that, I created a helper function add node. Add node is basically create a node, set the value to set the data to be V and the next to be V1, and then just say return that. And then what? If the list is not empty, you need to find out the last node and then change that last arrow next to be pointing to the newly created node. Right? So last arrow next is returning, is pointing to what add node, add node is returning. Okay? And then remember, what you return is what? The list itself. So the first node of the list doesn't change. So you still return L. Okay? So the only case where L, what is returning is changing is when the list is empty. For that case, we have to. But anyway, oh yeah. And then let's say we print. Let's say we print the list. So let's print a list. Okay. Not to remove this. Input data of the correct and one. That's print. Okay. So good. So let's say 10, 20, 30, 40, 50. Okay. So now add2back works really fine. More challenging is think about recursion. Okay. So how do you do recursion? How about recursive add? Here, so L is, if L is empty, then you have to basically return that node, and that's basically the same. You don't need to recurse, right? And now you have to change this case. Okay? When L is not empty, right? What do you have to do? Let's think about it. So we are only considering non-empty list, right? So let's say this. Right. Okay. And then you want to add node here. Right. What do you do? So think about recursion. Recursion is what? Usually this and the rest of it, right? So what do you think? For this one, when you're here, well, there's nothing to do, okay? Hey, I have my node. I cannot add node, okay? Next guy, next list. Think about adding node, okay? It's not my job. That's basically what it is. And then when the recursive goes when? So, and then at some point, you'll be reaching here, right? Meaning what? You'll be reaching the last node, like we did in the iterated case. That's the base case, right? Okay, I know I'm the last node. What I have to do? Well, now it's time, right? It's time. This is my job. I'll just add a node. Does it make sense? So it's similar, but here, what? If L is not empty, how do I check if I'm the last node or not? If L, I am, if L is not last, do nothing. L. If how do you say it's not last? Remember, if L next is not null, right? That's the case. That's how we find the last node. Right? Then what? Nothing. So nothing means what? Well, hey, what do I do? Hey, smaller list, please add. Right? Make sense? Otherwise, I know this is the case. Right? What do we do? Well, in this case, what do you have to do? You have to what? Set L next to be pointing to add node B. Remember, as before, what you return doesn't really change when the list is not empty. And that's basically the same for the add back in the recursive case too. But here, what you do is basically when this is when we are not in the when recursion is not on the last node, keep delegating the job. I'm done. There's nothing to do for me. Okay, you got to find out the last node. And then if you finally found out the last node, this is my job. This is my turn. I'll just set the next point to newly created node, and then we're done. Okay, so add that. Add to that. Sorry. Add to that. Add to that. Sorry.